Hello, today we will be learning 8.2 Pythagorean theorem in its converse. You guys will be able to prove the Pythagorean theorem using similarity and establish the relationships in special right triangles. So we have our Pythagorean theorem here. We've been using this a whole bunch all year already. In words, it says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So we have a squared plus b squared equals c squared. Just a reminder, C is always across from the 90 degrees. It is otherwise known as our hypotenuse. Okay, so just vocab terms, A and B, they're both legs, they're interchangeable. So we're going to practice some Pythagorean theorem. We've done this many times before. These should go really quick. Our formula is a squared plus b squared equals c squared. X is across from the 90, so it has to be c. A and b, like I just said, are interchangeable. So I have 4 squared plus 7 squared equals x squared. So I have 16 plus 49 equals x squared. Add these together, I get 65 equals x squared. Take the square root, so I get that x is either the square root of 65, or if I want to write this as a decimal, I just plug into my calculator, I get about 8.06. We also recently learned how to reduce radicals. Sometimes these sort of problems will ask you to write the reduced radical version. It really just depends. You'll have to read your question or look at your multiple choice problems. So next, once again, we are finding the hypotenuse. So I'm going to set it up basically identical. We have 5 squared plus 8 squared equals x squared. So 25 plus 64 is x squared. So 89 is x squared. Take the square root. These cancel. Forgot to do that over on this side. So x is square root 89, which is c. Go ahead and pause me. Try the try. Alright, on both of these problems we are finding the legs, so this sets up slightly different than what we were just doing. It is more like 8 squared plus x squared equals 12 squared. So I go ahead and solve, and I get that x squared is equal to 80. Take the square root of both sides, so I get that x is equal to the square root of 80. If I want to write this as a decimal, I just plug it into my calculator, I get 8.94-ish. The second one, we can tell by the multiple choice answers that it wants us to reduce our radical, so we'll do that. First of all, though, we have to solve. So we have leg squared plus leg squared equals hypotenuse squared. So now we have to take the square root here. I'm going to have to find my biggest perfect square that can divide 108 into like a whole number. And that biggest perfect square is 36 if I go through and check. 36 times 3 is 108. So when I reduce this, I get 6 square root 3, which is B. On the next page, we are going to learn about Pythagorean triples. These are 3 whole numbers that work in the Pythagorean theorem. Now, this is not something that you necessarily have to memorize, but if you notice these numbers, you can know your answer without doing any math. Okay? So, for instance, if we look at question 1, use the Pythagorean triple to find x, explain your reasoning. We're looking for the biggest side being 26 and one of the legs being 24. And I noticed that right here. That means x has to equal 10. So we're going to say x equals 10. The hypotenuse is 26. A leg is 24. So the other leg must be 10. Now, I can actually check that if I wanted to with just the Pythagorean theorem. Like I said, you don't necessarily have to memorize this. If you want to, you can just do the math every time. You do get that missing side length is 10. Okay, and the next one is a little bit trickier because it's not one of them that just shows up really readily in this chart here. It is technically a Pythagorean triple. It follows this sort of formula. So our hypotenuse is 20, one leg is 16. I know that the other leg has to be 12. Now, since it's not easily in our chart, and I feel like the Pythagorean triple is just like more to think about necessarily than what it's worth, I'm just going to go ahead and set up my formula and solve. And thankfully, we've had a lot of practice with these already this year, so this chapter should be, at least this part of it, fairly easy. Okay, go ahead and pause me. Try the U-try. Alright, so this says a 10-foot ladder is placed against a building. The base of the ladder is 6 feet from the building. How high does the ladder reach on the building? Draw a diagram to help visualize. So we've got a right triangle here, basically. The ladder is leaning against the building, it's 10 feet. The base is 6 feet away from the wall. We want to know the height that it reaches. Now, this is one of our simple ones that's already shown on here. It is this specific one. Our hypotenuse is 10. Our leg length is 6. That means our other leg length has to be 8. I'm going to show you that, though, in the Pythagorean theorem. All right. Now, we're going to use the converse of the Pythagorean theorem. It says if the sum of the squares of the lengths of the shortest side of a triangle is equal to the square of the lengths of the longest side, then we know this is a right triangle. So I'm not being told that we have a right triangle in this problem. We're trying to decide if it's a right triangle using the converse. And then we have inequality theorems. It says if the square of the lengths of the longest side of the triangle is less than the sum of the squares of the lengths of the other two sides, then it has to be an acute triangle. So we're going to set it up as if it's a Pythagorean theorem problem, but then we're going to figure out if it is acute or if it is obtuse. If the square of the length of the longest side is bigger than the sum of the squares of the lengths of the other two sides, then it is obtuse. Okay? So we're going to be comparing. We're going to classify these, whether they're acute, right, or obtuse, given these three side lengths, and we're going to have to justify. Now, anytime I mention my longest side, I'm going to call it the hypotenuse. They might not end up being a hypotenuse, though, if it's not a right triangle. I'm just going to use that term because it's the longest side. Okay, so to set this up, I'm going to take my, in quotes, hypotenuse, 15 squared. I'm going to put a box because it's either going to be equals, less than, or greater than. And And then I'm going to set up my two shorter sides. So I get 225, we don't know what, 81 plus 144. On this specific problem, once we finish solving, these do end up equaling each other. So this is right because a squared plus b squared equals c squared. Now, before we continue, I also want to mention, going back to an old thing that we did, where we need to actually check first to make sure these can make a triangle. Recall, to see if it makes a triangle, add your two smaller sides and make sure that is bigger than your larger side. So 17 is bigger than 15. Oh, I even did my math wrong. Sorry. I should say 21 is bigger than 15. So this is a triangle. If it's not a triangle, we can't even do the Pythagorean theorem, okay? It would give you some answer that doesn't actually mean anything. So first of all, this is a triangle, and secondly, it is specifically a right triangle. So, yeah, I skipped that on this first one. It says determine whether the measures of the sides can be a triangle. Same thing here. Determine whether the set of numbers 7, 8, and 14 can be the measures of the sides of the triangle. So let's do that step that I did second first this time. So we take our two smaller sides. That's 15, which is bigger than 14. So this is a triangle. Reminder, if it's smaller, it's not a triangle, so we have to stop there. Now, we're going to set up our problem. Remember, this is our hypotenuse in quotes. It's going to act as one because it's our longest side. So we have 14 squared is either equal to, less than, or greater than 7 squared plus 8 squared. So we have 196. We don't know. 49 plus 64. Once we finish doing our math here, our hypotenuse side, in quotes, is bigger than our other two sides. So if we look up here, if our hypotenuse side is bigger, it is an obtuse triangle. So we have to explain. We'll just put it over here. Yes, it's a triangle. The triangle is obtuse because c squared, or our hypotenuse in quotes, is greater than a squared plus b squared. Okay, you have two tries. Pause me for a second. We'll go through them. Okay, same sort of question as the last ones. First of all, we have to decide if this is a triangle. So add your two shorter sides. See if it's bigger than your longer side. It is, so this is a triangle. Then take your hypotenuse, your biggest side, put that in quotes again because it might not actually be the hypotenuse of a right triangle, and then see how it compares to the other two sides. And this is actually less than. So because our c squared, in quotes, is less than a squared plus b squared, this must be an acute triangle. Reminder to keep these separate from each other, guys. This math tells you if it's a triangle or not. This math tells you if it's right, obtuse, or acute. Don't mix them up, okay? Alright, last one. Determine whether the set of numbers can be a triangle, and then if so, classify. So I have 14 plus 8. That's 32. 32 is smaller than 33, so this is not a triangle. So we don't even need to continue on with any other math because it would be a nonsense answer. Since it's not a triangle, it can't be right, acute, or obtuse. All right, so that's it for our notes for today. Have a good one.